Welcome to our last lesson, Lesson 12 of Introduction to IT for Business course. Today, we will talk about cloud-based data management, its benefits, strategies, and tools. With the company growth, companies' databases grow, and managing large amounts of data becomes a challenge. Managers need systems that provide fast access and ensures data security. One of the most common solutions is to use cloud. Using the cloud to solve multifaceted business problems requires understanding cloud data management, staying up to date on best practices, and learning from other successful organizations. So the fundamental question that we need to ask ourselves is what exactly cloud-based data management is. Looking at widely accepted definition of cloud-based data management, it is the practice of storing a company's data on an offsite server that is typically owned and overseen by a vendor who specializes in cloud data hosting. The worst thing that could happen to your company would be the loss of all its digitally stored data, customer contact database, product inventories, personnel and payroll data, the company website, email systems. Data is the company's most valuable asset. Data is critical for three main reasons. The first reason, its negative consequence of losing. The second reason is the risk of lost revenue, lost productivity, and even lawsuits if sensitive data is not properly safeguarded. And the third reason is the positive benefit of being able to analyze company data for better decision making. The 7 benefits of cloud data management are: first one, security. Modern cloud data management is often more secure than on-premises solutions. In fact, 94% of cloud adopters report security improvements. First, because cloud data management reduces the risk of data loss due to device damage or hardware failure. Second, because companies specializing in cloud hosting and data management employ more advanced security measures and practices than companies that invest in their on-premises data. Second benefit is scalability and savings. Cloud data management lets users scale services up or down as needed. More storage or compute power can be added when needed. Companies can then scale back after the completion of a big project to avoid paying for services they don't need. The third benefit is governed access. With improved security comes greater peace of mind regarding governed data access. Cloud storage means team members can access the data they need from wherever they are. This access also supports a collaborative work culture, as employees can work together on a data set, easily share insights, and more. The fourth benefit, automated backups and disaster recovery. The cloud storage vendor can manage and automate data backups so that the company can focus its attention on other things and can rest assured that its data is safe. Having an up-to-date backup at all times also speeds up the process of disaster recovery after emergencies. The fifth benefit, improved data quality. An integrated, well-governed cloud data management solution helps companies tear down data silos and create a single source of truth for every data point. Data remains clean, consistent, and up-to-date. The sixth benefit is automated updates. Cloud data management providers are committed to providing the best services and capabilities. When applications need updated, cloud providers run these updates automatically. That means your team doesn't need to pause work while they wait for IT to update everyone's system. The seventh benefit, last but not least, is sustainability. For companies and brands committed to decreasing their environmental impact, cloud data management is a key step in the process. It allows organizations to reduce the carbon footprint created by their own facilities and to extend telecommuting options to their teams. The next we look at are models of data management. Every company's data management systems are different, but they all fall into one of two basic structures: silo and federated. In silo, each branch, department, or even individual worker maintains a separate storage system. The systems may be networked, but the data's physical location is still an important factor in locating and using it. In the federated structure, all data is available anywhere. The physical location of the data is irrelevant because anyone with the appropriate permissions may access it from anywhere in the world at any time. The silo approach. The silo approach to data management is the traditional classic approach. A company typically arrives at this structure organically as it grows. For example, a small business may begin with one server and one location and then add branch offices. Each branch office needs a server, so now there are two data silos, each self-contained. Then each salesperson needs on-the-road access, so a shared online drive is created. Now there are three silos. The human resources wants its own separate server, citing privacy concerns. Now there are four silos. Each salesperson gets a tablet and a phone. Now each employee's individual Microsoft or Google account is its own mini silo. You get the idea. Before long, a company's data systems are a huge set of individual data silos, none of which are more than slightly connected to one another. This approach works all right for the most part, in the way that small-town governments work all right without any state or federated oversight. Workers move along their daily activities, and money gets made and minor problems get discovered and solved. Maybe a server crashes and is restored from a backup. Maybe someone's iPhone dies and the data has to be reloaded. Maybe the HR director's laptop gets a virus and a couple of personnel records have to be restored from an archive. The silo approach has some drawbacks and limitations though. This approach, while it is basically okay for daily operations, has some endemic problems such as these. No easy way to locate data, because there are so many places data can be stored. Quickly locating a given piece of data can be difficult. Multiple file versions. In the course of everyday business, people email files back and forth, upload and download to shared drives, and even transfer files wirelessly from phone to phone. Rampant duplication. When each individual silo is backed up separately, your data has a great deal of redundancy. Inconsistent levels of protection. Without one central data store, it isn't a sure thing that all the data in all the various silos is adequately protected in the event of a large or small data loss. Nobody watching for problems. Without a central repository of data, you have no way to monitor data across the organization. And last but not least, complicated governance. If your company needs to ensure compliance with the internal or external regulations, apply a retention policy, or place a certain user's data on legal hold, having a variety of data repositories presents huge complications. The traditional silo approach has some significant limitations. An organization may have grown up with this approach organically, but at some point, and that point is actually sooner for most organizations, the silo model becomes no longer to be sufficient or a good value. The federated approach. Taking a federated approach to data management helps overcome many of the drawbacks of traditional silo systems outlined in the previous slide. And the cloud system is one of the best ways of achieving this federation. A cloud is a secure computing environment that users access online. The cloud can offer storage, processing power, applications, nearly anything that a physical computer can offer, but can scale on demand to meet any storage and computational needs. Cloud-based data management has many advantages over the traditional silo approach, addressing most of the problems we have pointed out in the previous slide. The word cloud is actually a very good metaphor because a cloud is somewhere out there in the wide open space of the online world rather than tied to one physical location. Cloud is viewable and accessible from many locations at once, and cloud is variable in size and shape with no fixed borders. Similarly, cloud storage is not tied to a physical location. This is a very attractive feature for companies with multiple branch offices all over the world and the country, whereas a particular silo exists in a specific office which might or might not be open when you need its data. A cloud service is always equally close at hand, no matter where you are. In silo-based storage, if a company needs to gather files for a legal request, someone scours each individual system to locate the required files, including physically obtained and copying devices that may be deployed remotely. In contrast, when using cloud to federate data en masse, multiple parties can have immediate access to the most up-to-date data at a moment's notice. If you store all your data in the cloud rather than individual silos, you can work with that pool of data as a federated whole. You can analyze it for trends, opportunities, and potential threats. You can back it up, you can search it, and you can expand or contract the available space to meet the company's needs. Cloud storage is infinitely scalable. With cloud-based storage, you never run out of storage space or processing power. The provider allocates or contracts resources as needed automatically, making your compute and storage pool fully elastic. When your company is smaller and needs less, you pay less. As it grows and needs more, your cost increases only incrementally. Understanding cloud services. A cloud is a secure computing environment that's based online. Many types of cloud services exist, from simple applications to full-featured software environments that support every aspect of a company's IT activities. A company, or individual for that matter, can employ a cloud service in any of these three ways. Software as a service allows IT to provide access to applications from the cloud rather than running them on their own internal systems. Most services also provide file storage. Platform as a service provides a cloud-based operating system on which companies can deploy their own applications, which they can then offer to their customers. Infrastructure as a service provides the cloud resources that enable platform customers to create and control their own platforms. You probably have come across one or more software as a service applications for handling data. It's common for end users to store and share files using systems like OneDrive, Dropbox, and Google Drive, and to use online applications like Microsoft Office Online. Although these systems are handy and can help end users be more productive in their day-to-day work, they don't do much for a company's overall data management. In fact, when users store files in individual online silos like this, they can hinder the company's efforts to keep track of data unless you are using a data management platform that is aware of software as a service applications and can interface with them. Many cloud-based services are more complex than simple applications, though they are entire integrated cloud stacks typically referred to as being cloud native. These integrated cloud systems in turn work with an infrastructure as a service provider that supplies and maintains the hardware. As with all computing systems, clouds rely on underlying hardware to operate. An infrastructure provider maintains huge rooms full of servers in warehouse-sized data centers, all secured and protected using the latest and most powerful technologies. These servers combine their resources to create a giant pool of computing resources, which can then be allocated dynamically to various cloud-native systems as needed. So even though hardware is involved in cloud storage, it isn't your responsibility. You don't have to buy the hardware. You don't have to maintain it. You don't have to protect it. Or you don't have to worry about it for that matter. There is a lot more to know about cloud services, but this explanation should suffice to help you follow along in your future professional activities. Centralized governance. In the context of data management, governance means applying policies that affect the way the data is stored, managed, protected, and made available. Every business has its own policies and principles on these matters. Some of these policies are internal decisions, but many are mandated by outside agencies, government regulations, court rulings, and industry standards. When all enterprise data is federated, governance can also be centralized. Executives don't have to worry about inconsistent policies across branches or inconsistently applied corporate policies causing embarrassment, inconvenience, legal challenges, or worse. Instead, companies can increase visibility into business data dispersed across laptops, desktops, servers, mobile devices, and cloud applications. Companies can also ensure compliance with all applicable regulations for auditing, investigation, and e-discovery needs. Companies can also fine-tune security and privacy settings for different kinds of data, different data residency requirements, and different user roles. And companies can also protect data on remote devices with geolocation, remote wipe, enforced encryption, and other security features. Cloud native technology. Cloud native means your technology is built from the ground up to leverage the benefits of the cloud. A true cloud native data management approach doesn't simply throw a cloud connection onto existing management systems. A cloud native approach takes advantage of the unique features of a cloud to manage data in smarter, tighter, more efficient ways than were ever possible with traditional data management systems. Because it does not require an intermediary layer between older deployments and the gateway appliance, a cloud-native approach eliminates bottlenecks, boosting both performance and availability. This type of approach also offers versatility, allowing enterprises to use it as a convergence point for other important activities. It doesn't use a cloud storage as the technological equivalent of a warehouse. Rather, the data can be used for many purposes, including backup, disaster recovery, and legal investigations. The idea of cloud data management is to both simplify and enhance an enterprise's ability to protect, archive, search, govern, and analyze its data. Best practices for a cloud data management strategy. Managing data in the cloud is going to look very similar to managing an on-premises data store, with the few extra considerations. Many cloud providers will help with some aspects of data management, but a company is ultimately responsible for their own data management. First, start with the plan. Dumping data into the cloud is not cloud data management. Will you move all data to the cloud or create a hybrid environment? Who needs access to what data? Where should different processing tasks take place? Second, maintain clean data. This is incredibly important as other data management practices depend upon it. Keeping the data clean means ensuring that the data entry is accurate and that there are no duplicates or other errors. 3. Backup the data. Most cloud providers will automatically run regular backups. If a company is hosting its own cloud, however, make sure the IT department is running regular backups. 4. Don't forget about data governance. An existing data governance policy for on-premises data can be updated for a hybrid or cloud data management architecture. Moving data to the cloud, however, often means extra compliance issues need to be considered, so make sure those don't slip through the cracks. Examples of successful possible cloud data management. Cloud data management for healthcare. Company A is a healthcare information service provider that aims to improve the experience, outcomes, and cost of healthcare for providers and patients. Company A uses a cloud data management system to merge data from diverse medical records, both from the patient and the patient's family members, in order to compile the most thorough possible portrait of the patient's medical history and potential risk factors. This allows the doctors and hospitals to access the most accurate and complete information available to them when making important decisions regarding their patients' health and well-being. Cloud data management for finance. A wealth management company B needs to be able to generate frequent detailed reports. If the data is difficult to access or only certain people have access to it, the reporting process bottlenecks. Company B uses cloud data management to improve governed self-service access to data and dramatically reduce the average amount of time required to generate reports. Cloud data management for agriculture. Company C has created a machine learning tool to help farmers identify the types of weeds growing in their fields just by uploading a simple photograph. Although the process may be simple for the farmers using it, the technology behind it is fairly complex. Company C hosts a large amount of plant data in the cloud and uses it to train a machine learning algorithm. This algorithm can identify the weeds growing in the fields and help farmers make good decisions about the best way to handle the current growing environment. This lecture summarizes the course of Introduction to IT for Business. I hope you have enjoyed it and acquired interesting takeaways and important skills that can help you easily manage and utilize IT for any of your future business needs and purposes. I hope this course gave everything that you will need in your future studies and career. I wish you to succeed in your final exam and in your overall academic journey. I hope to see you in the future in other courses. Bye-bye. Thank you for your attention. We will have our Q&A session during our lessons. Please check your timetable. If you have any comments, questions, or suggestions, please feel free to email them to me. Thank you very much. Bye for now.